Today what we're going to be doing is having a look at how to generate a COMET phase file using the Access phase file generator. Now this phase file generator normally comes with the training course when we do the training. Now you can find this file also at the COMET support website. It's one of the files that you can download here. So once you've downloaded it, I'm going to show you how to set it up. Typically, when you take data from a block model, bring it into this phase file generator, do the processing required to generate COMET phase files. And that once you have the phase files, you can put them into the COMET optimizer and start running schedules. So it's kind of a key part that we need to be able to do. Now, there's other ways to generate phase files. One of them is Deswick software has got an interface to generate COMET phase files, and also Hexagon have generated a interface to create COMET phase files. Also, people can write their own scripts to take information out of Vulkan or Deswick or Hexagon, really whichever MineSite packages you're using. Okay, so what we're going to do, there's only two files that we're going to look at initially. There's this database file and there's this text file. Now the text file has simply got a dump from the block model. So you'll see here, you can have a comma separated file, or this a tab separated file. You'll typically have the northing, easting, elevation, and a few different properties of the rock, including the phase number that the block is going to be mined with. So you need a phase coded CSV file or ASCII file that we're going to use as the starting point for the phase file generation. The first thing we're doing is opening up the Access database. And what you see is you've got a panel on the left-hand side and then a menu here. Let's just, on the panel on the left, if it's not already selected this way, just show the tables. And on the right is a little menu that we can use to control the main tables that are being used. So let me firstly take you through the general parameters. And we'll see tables here that are used in these general parameters. So the first thing that we have is we have a subdirectory where these phase files are going to be written into. So this is going to be in the parent directory. That's what the ... means. Parent directory, phases, 1D. So this is a one-dimensional version that I'm going to be showing you. And then we're going to have the word phase, then the phase number, and then .text. That'll be the name of the file. So that's what these first three parameters are. Now the next parameters are for the block model. Now within the database, you need to take that ASCII data file and put it into a table within Access that you can use. Now the good news is that there's normally IT type people around that you can get some support from. So you don't need to be a COMET expert for this, you just need some database help. And there's also tutorials and things like that that you can look at to better understand SQL and in particular Access. Okay, so the first thing that we're going to, or the first set of parameters are for the block model. So we have a table where the block model is going to be stored. So the table name here is block model. You can see over in here we have something called block model. So we'll have a look at that shortly. Firstly, there's which column is representing the phase name. What's the elevation column? What's the column with the mass in? And we're going to end up subdividing each block into bins, into cut-off grade bins. So which column is going to contain the bins? Now, typically, when you get the data from a general mining package, you typically won't have the mass and you won't have the bin number. So these are extra columns we're going to need to add. And what we'll do is we can fairly easily calculate these numbers, but initially we'll just import the data without those columns and then we'll add the columns in. Now, the block model table is the main table that contains the data, but we also have a couple of other tables. The first table is what's going to store the information that we're going to write out, or the codes that we're going to write out. Now, you might have quite a lot of codes, so what we've done is we have the base name for the codes tables. So we'll have, in this case, we've got something called just codes. So there'll be a table called codes 1, codes 2, codes 3, and so on. So you can see over here, in this case, we've just got codes 1. If you had a lot of codes, you could have another table with codes 2 and codes 3 and so on. Up to 10 different codes tables. Then the other thing we have is some cut-off grade tables. Now, the cut-off grade, the base name for the cut-off grade table works in the same way. So if you've just got one dimension, you'll have one table called, in this case, COG_intervals 1, and that's the first dimension. If you had multiple dimensions, you'd have COG_intervals 2 and 3, and so on for the second and third dimension. So you can see over here, we have COG_intervals 1, but we don't have a COG_intervals 2 and 3. So that's because we just have a one-dimensional phase files that we're going to be creating. You can see in some other examples here, we've got a two-dimensional cut-off grades where we've got COG_intervals 2D, 1, so the base name is COG2D, and then 1 is the first dimension, 2 is the second dimension, and so on. Okay, the next thing we have is we have two more tables. One's a metallurgical table and another one's a haulage table. Now, you don't need to use these, but we typically find that this is a useful way to add some additional information that's not put into the block model. So in this case, we have a metallurgical table called MET table. So you can see over here, here's the MET table. And we need two fields for this. Now, if we use the metallurgical table, we need to have a link between the metallurgical table and the block model table. So that's what these two fields are here. The first one is the code in the block model table that describes the rock type. And the second one is the code in the MET model table that describes the rock. And then these two tables will be matched. And then when we come to report information about a block, we can also pick up both things from the block model table, like the ore grades, the copper and the gold and the zinc grades, but we can also report metallurgical tables for that rock type, like the recovery, concentrate grade, and those sort of properties. Now, the second table that is also optional is the haulage table. So in the haulage table, we have a similar link that we need to do. Now, we already know the phase in the block model table and the elevation in the block model table because they were reported up here. But what we need is similar links into this haulage table. So in the haulage table, we need what's the name of the field in the haulage table that contains the phase name, and what's the field that contains the elevation. And again, these two tables will be linked, and then if you have some numbers in the haulage table, for example, your cycle time from a particular block to the crusher, from the block to the waste dump, perhaps some sinking rates even, you can put those all in this one table with the haulage information, and they can be linked together and joined to create a phase file with all of that information in it. So let's have a little bit more of a look at the tables themselves. So firstly, the block model table. So here we've actually already imported the information into the block model. So we're going to be going through exactly how we do that in a minute as well. But this is where we're trying to get to. So we'll end up getting the northing easting elevation, the copper and zinc. You can remember those from the ASCII table, ASCII file that we were just looking at, and some more properties. Now, we didn't have the mass, and so that's something that we still need to calculate. We didn't have the bin number. In this case, we've got a ranking and a second dimension ranking as well. So you remember in here we had something called pit. So this is the pit column. So that's got the phase name in it. And so later on down here, you'll see that we've gone from pit 1 to pit 2, pit 3, and so on. And we've also got something, the elevation column was this one here. The mass and bin are two other columns that we've constructed here. So let me show you how to start with the text block model file and bring it into a table like this. So the first thing I'm going to do, I'm going to just rename this one just so that I can bring it back if I need to. So now the next thing that we're going to do is we're going to import the data from that text file. So if we go to external data here and say new data source, so it'll be from a file, from a text file, browse and find the name of that file. Okay, we're going to import the source data and put it into a new table in the current database. Now here we need to have pick what the delimiter is going to be. So I'm going to use a delimited file rather than a fixed width file. My delimiters are going to be tabs. I'm going to use the first columns for my delimiters are going to be spaces. And the first column contains the names of the fields. We say next. We'll just check as we go through these. The easting is going to be of type long integer. Might actually make these all doubles. The elevation, I'll make a double as well. The copper, we don't want integers, we want doubles here. The zinc, the density. The rock type, we're happy with an integer. The phase name, now the phase name is actually a text file, a text column. So once we have done that, we'll click next. Now the primary key is going to be a combination of these three. Now Access doesn't let you do that, so I'm just going to not have a primary key at this stage. I'm going to import it into a table called block model. And if you want to, you can do some analysis after the import. I'm not going to worry about that. And say finish. You can also save these steps in case you want to do them again. It's quite common that we need to go through this process again. Perhaps some of the data's changed, you've got new block models, new phase design, so saving these steps is often a good idea. And then you can pick that up later. Okay, so now we've got a new file called block model. So this is the information that we just had in the previous table. Now, you see our phase is called phase num. It's not called, in this one, it was looking for the phase in the pit column, but we're actually going to make the phase num the column which has got the phase in it. Now you notice it doesn't have the bin and it doesn't have the mass column. So what we're going to do is to add those couple. If we look at the database in this design mode, we can just come down below and add something called mass, which is going to be a number, type number, and make sure it's a double. You can add a comment if you like. And we are also eventually going to need another one called bin to put the bin of the bin of the cutoff grades, the cutoff grade bin. And we'll make that, that can be an integer, that's fine. Okay, if we save that, then you notice in our block model table, now we've got these extra columns, but they're not populated. So the first thing we're going to do is we need to manually populate the mass column. Now, I have some scripts, some sample scripts in the database that you can use. So if instead of looking at the tables, you look at the queries, down here you'll see one of these queries is a sample of how to calculate the mass from the density. So this is where you need to know a little bit about SQL, or it'll be helpful to have someone who knows a little bit about it nearby. But you do have some examples here as well that you can use. So if we open this in design mode, what this does is it calculates the mass field by looking in the block model table and getting the density times then we put in the volume. So if we know that the volume is 5 by 5 by 10 or 50 by 50 by 10, then we can calculate what's the volume and put it in here and then calculate the mass field. So once you've worked out this formula, exactly how you want it to be, you can also sometimes add the percentage of the block that's below the topography. So you might have the topo proportion times the density times the volume of a full block and calculate it that way. So to run this, we go to the design options and click run. So it says I'm about to update 20,768 rows. That's actually how many rows in total I have in the block model. I'm going to close this down now. I'm going to go back to my tables and have a look at my block model. And now you'll notice the mass column has been populated. Now, the next thing I want to do is to populate the bin. Now, we have some ways to populate that for you based on the cutoff grades that you use. So if we have a look at the cutoff grade tables, you remember in here, the cutoff grades tables are in this cutoff grade intervals table. And we just have one of these because it's the first, it's only got one dimension. Now, what we do is we calculate a ranking and then we put the bin into a particular interval based on the ranking. So before we can do this, we need to calculate the ranking. So we don't actually have a variable in this table called ranking. So we're going to add one of those. So because we've got both copper and zinc, we're going to do $1 per tonne type cutoff grade that combines the value from both of the copper and zinc. So we've got a ranking now in here. We'll save those changes. So if you look at that, there's the ranking, but there's nothing in it. It's not been populated. So if we go to the queries again, you see we've got a sample way of calculating the ranking as well. So if you open that in design view mode, you can see now it's actually written it in an SQL way. So this is where it is handy to know a little bit about the how to make SQL update queries. So what this is doing is it's taking the block model data, it's actually joining it to the haulage table, and it's setting the ranking to be equal to the copper times some factors here, turn it into from a percentage back into a copper grade, multiplying it by 2.5, which is a recovered value with the standard, well, it's a price without a recovery, or it would be better to calculate the price with the recovery. So this is a very simple version of the ranking system, but you can actually put a much more detailed ranking calculation into here that includes the haulage hours and the throughput, those sort of numbers. This one's just got the copper grade, basically times the copper price, the zinc grade times the zinc price, plus it's got the processing cost in here as well, which is -2. So we're going to set the ranking variable to that and we're also going to update the block model bin variable to be -1. So if we run this query, our pit is now called phase num. Okay, so if we run this query, we're going to update all of the variables. We close this, saving it because I changed the name of the phase there. We have a look at the block model, and now we've got our ranking variable set. Now if we have a look at our block model table again, we notice the ranking here has been calculated. So now based on this ranking, we're going to look at the different cutoff grade intervals. So when we have a look at these cutoff grade bins, you can see here a ranking variable of 19.8 would go into this bin 6 here. So we should populate this bin number with 19.8. Now, we have a little way to help you to do that. So based on these general parameters here, the next thing we want to do is just create a little list of the phases. So this button goes through the block model and analyzes all the phase names in there. And then you can see that we end up, there's only 3 phases in this one. And so 1, 2, and 3. So it just calculates that. Then what we do is we click this button. So you can actually have multiple sets of this data. So I'm just showing you one set of data, and that's why we're going down here. If we actually have multiple sets of data, you can go down this other side. So for the one set of data that we've been looking at, if you say update the ND cutoff grade, so you can see the query running down the bottom here. And then if we have a look at our block model again, now we have this bin that's been populated according to the cutoff grades table. Now the next thing that we're going to do is we need to write out the phase file. So before we do that, we'll just have a look at the codes table. So we'll just have a look at these parameters again. So we'll have a look at the codes. Now the codes table just shows all the fields that are going to be written out. So we always write out the elevation, the mass, the bin number. We always write out those 3. And the next ones that we want to write out is the ranking, the zinc, the copper, and so on. So what this does, the first column tells you the order that you want to write out the information. The next column is an alias for the information that you want to write out. And the reason you need an alias is that you might need to do some calculations in here. So if it's just the ranking, then you don't really need an alias, but you still need to give one for this script to work. So it just can't be the same name as one of your columns. So that's why I've got the ranking, because it's a little bit of Italian coming out in me. Okay, so we've got the ranking that will calculate the ranking. It'll take the ranking variable, which is in dollars per ton. It'll multiply it by the mass to weight it, and then add them all together for all the blocks, and then undo the ranking, and it'll write it here. Then we've got the zinc, that's fairly similar to the copper. We're writing out a copper equivalent, which is a simple copper plus zinc, just to give you an example of that. This information here, the ore haulage, waste haulage, and stockpile haulage, aren't actually in the block model. It's coming from the haulage table. So I'll show you that in a minute. We have some fixed numbers in here, just how long does it take to get the 2 different exits. The sinking rate, that also came from the haulage table. The zinc and copper recovery came from the metallurgical table, so we'll show you that as well. And you need to just think about how these are going to be weighted. So things like the copper recovery needs to be weighted by copper metal, not just by mass. So that's where you can get the mass times the copper to weight it properly. Some of these need to be inverted as well before they're written. And so that's what this tick box here is. So if you get the sinking variable, which is like a millions of tons per year, you invert it to get years per million tonnes. You multiply it by mass to get years, and then when you write it, you need to invert it again when you undo the ranking, to turn it back to millions of tonnes per year. And then we normally write all these variables out too. I've got a phase name here that is not actually written out to the phase file. Now, I often find the easiest way to make changes in here is to use Excel. So I'll show you how you do that. If you get the fields that are being used, if you wanted to, for example, change the order of these fields, it's often easiest to do this in Excel. This just needs to be a sequential order. And then if you want to change the formula in here, if you made this times 2.5 plus the zinc times 1.1, actually, times 1.1 divided by 2.5. There we go. So you can change these numbers in Excel quite easily. Copy those, go back to here, delete the records that are in here, and then paste them back in. So I often like to use formulas to make sure that these fields are just the way I like them. So you can do that in Excel. I normally find a little bit easier. Okay, so these are the variables that are going to be printed out. Let me just show you some of these ones that come from the haulage table and from the metallurgical table. So let's look at the metallurgical table first. So you remember in the MET table, we had a rock code in the block model and a MET code in the MET table. So if we just open up this one, you see we've got this rock type here. So that's the first of these parameters. Then if we look at the metallurgical table, you can see this MET code here links the rock codes to these ones here. So rock type 3 will actually have a copper recovery of 85%, a zinc recovery of 72%. And then the haulage table is similar. You can see in the haulage table, we need to know where the phase name is and where the elevation is. So we've got something called phase in the haulage table, so it doesn't have to be the same name as in the block model table, but it's called phase here, and the level is here as well. And then we've got the ore haulage time, the stockpile haulage, these are in tonnes per hour. Then we've got the sinking rate, which is in millions of tonnes per year. So all these variables are now accessible and can be written out when we write out our phase file. So the next step is just to write out the phase file. So you see we want to put it in the parent directory, and then the next directory is phases and 1D. So if we have a look at our directories where we are here, the parent directory is from phase generation up to phases. Underneath that, it's we have a new folder called phases. Underneath that, we have something called 1D. We can delete these files just to show you that they're going to be generated. And then, so all we need to do now is say write selected set. So you can see phase 1, 2, 3 is being written. So these are quite small phases, so they don't take very long to write. If we have a look at what's in here, these have just been generated. If we open up these, you can see when it was written, the name, the path where it was written to, and this is the standard COMET phase format. You'll recognise a lot of things. You'll recognise the bins here. You'll recognise the ranking, the copper, the zinc, the copper, and so on. This is maybe a difficult way to open it. If we open it in Excel, that will look a little bit easier to read. You can do some checks in here. I'll often select a column, have a look at the mass, make sure I've got all the mass in the phase before I import it into COMET. Okay, so now that you have the phases, then you can start bringing them into COMET and start doing some optimizing. So make sure you do some checks on these phases. Once you've run them with a couple of schedules, do some sanity checks like the total mass, make sure that you've not created or destroyed mass or double counted mass, things like that. Do the same thing with some of your key variables like copper and zinc, make sure you haven't created copper. Do some break-even cutoff grades or some constant fixed cutoff grades to make sure that the amount of you haven't created metal, you haven't lost metal. Just a few sanity checks like that. And then go for it to optimize your mine. We'll see you next time.